In the next two examples, we want to solve a polynomial equation. If we think back to the quadratic formula, that was something that we could use to solve a polynomial of the form ax squared plus bx plus c. So that was a second degree polynomial. Now we're dealing with a third degree polynomial in each of these cases. So the quadratic formula doesn't work. We need another approach. And in this case, what we're going to do is look at factoring this by grouping. We'll consider the first two terms as a group, the second two terms as a group, and we'll see what greatest common factor we can pull out. In this case, between 9x cubed and minus 27x squared, we can factor out 9x squared, which will leave us with x minus 3. And then from the second two terms, we want that leading term to be positive, so we'll factor out a negative 1, which will leave us with x minus 3. We know that we're on the right track because the two expressions that we have left over after pulling out those greatest common factors match, meaning we can factor out x minus 3, which is a factor that's common between these two terms, leaving us with 9x squared minus 1 is equal to 0. From here, we can take one more step to factor. Using difference of squares, this will factor as 3x minus 1 and 3x plus 1, giving us three solutions. X is equal to 3, 1/3, and negative 1/3. In example 5, similarly, we'll look at grouping. In this case, we only have two terms. So we'll start by factoring out the GCF, which is 4x, which will leave us with 9x squared minus 16 is equal to 0. 9x squared minus 16 can again be factored using difference of squares. So we'll end up with 4x times 3x minus 4 times 3x plus 4. Which will leave us with three solutions: 0, 4/3, and negative 4/3.